This is tutorial about Automower's front wheel repair and modification, which will void your warranty. First thing to do is to remove a body kit, as this makes easier to repair front wheel. This type of repair should be done after every season because tire wears out and loses its rigidity, and gap starts to form between tire and plastic, and moisture will start to penetrate inside this wheel. Secondly, since the tire rigidity has been lost, more and more pressure is applied on those plastic parts here, which means that they will get scratched up and eventually damaged. To take this wheel apart, we need a T20 Torx screwdriver or T20 Torx bit, which is on socket adapter. But I don't like this because this socket adapter is too big to fit inside this hole. Remove 3 screws. Pull wheel apart. As you can see, some penetration has been occurred, and this O-ring actually is dividing this wheel into 2 compartments. One is where tire and plastic parts are, and the second one is where ball bearings and lock washer is situated. And this is most critical one. Actually, even if here is moisture, this O-ring should protect ball bearings and this lock washer from rusting. But as you can see, there are traces of moisture, which means that there are this oil seal, which is underneath here, has not been performed correctly and has been worn out. When this lock washer starts to rust, eventually it will break, and if it breaks, the whole front wheel is coming off, and this robotic lawnmower can mow without one wheel, which means that eventually it will ride over one wheel which is on the grass, and this one wheel will get damaged. To remove this lock washer, you need 2 screwdrivers. One is one smaller flathead, and second is bigger flathead. First you take a smaller one and put it between ball bearing and lock washer, and make a small gap here. Once the gap is big enough so that the bigger flathead screwdriver can get inside, you will make the gap with bigger one bigger, and eventually this lock washer starts to come off. Remove this washer and then remove this ball bearing. Which is pretty stuck here, so I need to use a bigger screwdriver. And once this is removed, remove this plastic by holding the spindle and pulling this plastic off. And as you can see, there is second ball bearing and oil seal. Since we had moisture penetration inside this wheel, this oil seal is no good, and we have to replace it. The second ball bearing is the most important one because it's taking most of the pressure from the wheel, and very often we can see wear marks on the spindle, and if this ball bearing starts to rust inside because there has been moisture, eventually it starts to slip, and this spindle wears out so much that we have to replace the whole spindle or the whole wheel assembly. But next we are removing this ball bearing, which is pretty stuck here, and then we are removing this O-ring, and then we are removing this shield kit. Actually, this is not that bad. This is only this robotic lawnmower has been used only for 1 season, so the moisture penetration has not been so significant, and the slippage has been very, very small. So here is an example when users think that if robotic lawnmower mows, then everything is fine. Actually, you should perform checks weekly to see problems ahead, and as you can see, this wheel is very loose, and this means that this kind of looseness means that there has been ball bearing failure, and if ball bearing fails, you end up like this. As you can see, this spindle has worn out due to ball bearing failure, and so has worn out this shield kit, plastic and inner ring. Therefore this whole spindle should be replaced, but the problem is you have to take upper and lower chassis apart to replace this spindle, and it takes much more time and costs more. This is one of the plastics, a new one basically, or untouched one, and this is a worn one, and as you can see there is very big deformation, and this is due to a ball bearing malfunction, and we have to replace this part for sure. So next, clean everything up you have removed and soak it in water, soapy water for example, and use soap and water to clean everything up. And secondly, do not remove this metallic ring from this plastic, because you simply can't use pliers to remove this metallic ring, because you will start scratch this outer surface where oil seal is slipping, and when this metallic ring has been scratched, the oil seal starts to wear off pretty fast. And secondly, of course, you can use leverage to pry this metallic ring off, but then you will damage this plastic here. But you have to push this metallic ring back inside this plastic housing so that this metallic ring doesn't protrude, and the inner plastic part and the metallic ring surfaces are flat. To push this metallic ring properly inside, put this plastic on a flat hard surface and take a screwdriver and push this screwdriver against this plastic part very hard, and if you apply enough pressure, this metallic ring will go flat, so that the inner plastic part and the metallic ring is completely flat. And this is very important because every millimeter counts. Next is to get an angle grinder and grind this part down slightly. This is approximately originally 46 millimeters from the knob, and we need to grind it down approximately 44 millimeters. So basically take off from here 2 millimeters, because spindle will touch this plastic part. When we compare, you can see this is touched one, and this is completely original, which doesn't have any touch marks. So therefore we have to grind slightly this spindle down. And then start putting everything back together. And when pushing shield kit back to spindle, make sure that the shield kit's recesses line up with spindle's knobs. Just like that. And then take silicone grease or any other grease which is safe for plastics and for rubber, and start greasing inside here, just like that. And next we need to take this plastic part and take a flat file and file this part very slightly. As you can see, this is original and this is a filed one, so that you can see I removed so little material that you can see there is a still inner lip, and if you grind out too much, then it is a higher likelihood that this plastic part will start to damage one of the ball bearings which is against this side. Next, take a ball bearing 688 which has contact rubber seals, and if you are reusing ball bearing, test its rolling resistance by rolling this in your hand. If it's rusted or there is a wobble, you need to replace it for sure. And then push this ball bearing inside here like that, and take then a little bit grease, silicone grease, and put it here. Not that much, but just slightly. Just like that. And then take oil seal. We have to use a new one because this one leaked, and install it like that. Then install this plastic part back to the spindle, just like that. Then wipe off the excess. Then take a good ball bearing 688 and install it. Next, take a shaft lock collar and grease its screw so that it won't rust so harshly, and then put it here, and then apply pressure with your hand and tension this Allen or hex key. Don't use any kind of mechanical clamp, for example par clamp, because par clamp applies too much side pressure on ball bearings, and this leads ball bearing premature failure. Then take O-ring, which we removed previously, and install it here. This O-ring has been greased with silicone grease, so it would fit more easily. Next, take a milling cutter which has outside diameter of 16 millimeters, and put it on a cordless drill, and this is original, but with this milling cutter it needs to be like that, just very slightly cut it out, but be very careful, as it's very easy to cut through this part here, and if you have got it through, then it's possible to plastic weld it, because this material is thermoplastic polypropylene. After you have modified this part, take an O-ring which has outside diameter 90 millimeters, inside 80, and width 5 millimeters, and put it over this plastic part. And try not to twist this O-ring. Also make sure that there are no chips missing from this edge, otherwise moisture can penetrate inside this wheel, and if it's missing, then you can replace this plastic or you can plastic weld it. The purpose of using O-ring is to use old tires, otherwise we have to replace tires every year. As you can see, this new tire has this reach, and when you are reusing old tires, you have to make sure that you still have proper reach here, and if you turn it over, there's also a reach. If there is some parts of this reach missing or it's worn off, you can't use old tires. I'm just giving you a few examples here. As you can see, this reach has worn off. This is an old tire which we can't use because this side of the reach is completely worn off. Compare, we have this reach here and we don't have it here. Also, if we take, there is one example when the reach has partly worn off, but this is also no good because moisture will penetrate. Compare it with this one. You can see this is pretty good reach. This is no good reach. Some of the viewers might be wondering, why do we need to do so much shaping and grinding and modifying? This is because this shaft lock collar doesn't fit otherwise inside this wheel, and the main problem is that this is approximately 7 millimeters wide, and if you have any other solution, better solutions for this problem, maybe thinner shaft lock collar which inside diameter is 8 millimeters, and it also has to fit inside this plastic housing which is approximately 20 millimeters. Then write it down in the comment section. But right now, as of right now, I haven't found any better shaft lock collar. And by the way, I'm recommending to use stainless steel shaft lock collar, because normal steel starts to rust, and sometimes this hex screw is so rusted inside here, so we need to drill it out. Next, find O-ring which outside diameter is 4.5 millimeters, inside 2.5, and width 1 millimeter, and take a Torx screwdriver and screw it on here, because problem is originally there is no O-ring here, and some of the moisture will penetrate through this screw. Before screwing this wheel back together, you should learn how to screw metallic screws inside plastic threads, and for that you need to turn screw counterclockwise until you hear a click or feel a click. Just like that. And then turn the screw clockwise, and then you will avoid cross-threading plastic threads. Then take a wheel with a tire and a screwdriver which holds the screw, which has the o-ring, and then put it in the hole so that the screw is penetrating through this hole. And it's very hard to film it, but you can see and align this screw with this hole here, and if you do it properly, then turn it counterclockwise, you feel the click, and then start screwing clockwise. Don't screw it all the way in, like maybe half in. Then add another screw and repeat the process, like half in, then next one half in, and finally last one half in. And once you have screwed every screw in, then tension them all the way in. After you have done all of that, your wheel should turn normally, and there shouldn't be any plane in there. But if your wheel is turning very hard or it's stuck, then it means that you need to grind this part down a little bit more. So this is how wheel inside should look like after one season. This o-ring did its job correctly, and this is an example what it should not look like, and there is no o-ring. One thing to note is that this tire is much higher than it was before and originally, and if you put here a too big o-ring, let's say you put here 6 millimeter or 7 millimeter width o-ring here, you may have problems with charging station, because mower's front end is too high to fit inside charging station. These types of wheels are being used by models 420, 430EX, 440, 450EX, and enterprise models 520, 550, and 550 EPOS. Some of those models have been produced from 2016, and Husqvarna has not changed its design. For me, it's pretty strange, because as you can see, there are many design flaws. In my opinion, the spindle should be shorter. There shouldn't be this lock washer, which is pretty thin and starts rusting after some time. And there should be O-rings behind every screw, so that the moisture will not penetrate inside the wheel. And the tire should be wider, so 5 millimeters, so that you don't have to change out the tire after every season. If you want to repair models 310, 315 and 315EX, then you can, but you have to remember that these types of models use different kind of spare parts, because these models have spindle shafts diameter 6 millimeters, not 8 millimeters. Also, ball bearings are different, shield kit is different, and if you replace the lock washer with a shaft lock collar, then also shaft lock collar inner diameter has to be 6 millimeters, not 8 millimeters. In my opinion, Husqvarna is very well aware that these types of wheels are the weak point of this robotic lawnmower, because from 2022 there's no longer standard 310 and 315 models. Instead, there is 310 Mark II and 315 Mark II, which doesn't use anymore this type of wheels. The newer concept of those wheels are much better.